Switch that one on. That one's on. That one, yeah, this one on both. We go quick. One, 2, 3. 1, 2, 3. Lapel 1. 1, 2, 3. 1, 2, 3. Come on, I'll switch them on and I'll keep that. I've moved it the files. That was the u3a. Yeah. It's now live on YouTube as well. I've got a bit of a church, you'll see now, but I've put a bit of sign through it now. Audio. That's the general hubbub of the church. Oh, that's me speaking.
I've got one up here, tested and making that fine. Can I have it if you've done? That's probably too tiny.
Where you've got to stand up, or you'll be at your laptop, of course. Yeah. Laptop is.
So will you switch me on and off? John will do it for me. And this one's live as well.
Oh no. It doesn't work. What's that? It says it's got missing flags. Missing flags? Can we just take a seat? I'll show that on the screen, yeah. It is on the screen, yeah. So how would I? Right. You click it. Well, let's just try it. Each word. It is okay. Let's just keep it. Now, there are videos embedded in here. Alright, so usually it's the second click starts the video. Can do, but sometimes I need to shift them along. So if all those fail, where the files are in the folder between. If we put the folders in there. Oh, I forgot. That's the one. Aye.
Well, he's just playing in itself.
Oh, is that it there?
Well, no, that's on the platform.
Oh, that's on the you want me to...
I'm not playing, he's just in there.
Oh, it's off again, yeah? Oh, right. Ah.
It's difficult when you can't really see when you're...
No, that's right. Oh.
I don't know if you're allowed, but can I get you tea?
A cup of tea. A cup of tea, yeah, you could stick it in. We've got technical difficulties and we drop them off.
Oh, we don't. No sugar.
No sugar. More than that. We drop.
Just hold it in slide.
Oh, so the
No, hold it in slide. No, don't want to play from this.
Okay, go on this slice. Yeah. Usually, I say it's running.
Yeah, it's just I want this to go forward to 2 hours.
Oh, right. So the video is running.
Probably just have they got the sound?
We will have sound as well.
We will have sound.
So we'll just try it. Is that the video that's embedded? Yeah.
So we'll play them in 2 bed. I'll play it straight through rather than... let's keep it separate.
But basically, a second, when you come to that slide, the second click, you move it forward. Or you can take this right now. Shall we put that back to the start?
Put it back to the... Put it back to the start.
Play that. Was that quite case? Oh, there we go. I'll put that right back to the...
Just back to the start.
That starts.
Okay, so we're on start, so we leave it set up like that.
If there's something wrong with the cooker or you want an advanced slide, I've got control here as well.
I'll just go and
There's a wee on off switch on.
I'll just go and try to pick.
Okay.
Good morning. We've had one or two technological problems to work out. Fortunately, I don't have anything to do with that. I would need to mention, though, that to be conform with Church of Scotland guidelines, that if you're not actually drinking a coffee or speaking, they would like you to keep the mask on. On that note, I shall hand over to David.
Thank you, Robert. The first thing I'm going to report, this will only apply to those people who have been members for more than about 15 or 16 years. Unfortunately, I've got to say that I received recently the news that Bruce Cannon, who was one of our chairmen in the mid-2005, 2006 era, has died recently. The Cannons were well known to the older members of Perth u3a, so just to bring you up to date on that one. Diaries. David is out at the corner there, just out the entrance there with diaries. He's still got 4 to sell. So if this is almost your last chance this year of getting one from him, although you can actually always give him a ring and he'll send one off to you. On group, we've got some good news. There's Art Appreciation is starting again, back in operation under new stewardship, and also we've got a second lunch group started. Now, if you're interested in any of these things, you'll find more information on the website, and you can also query, send an email to the leader and find out more about them if you're interested. The last news roundup was advertising for people who wanted to become a string musical group. Unfortunately, only 2 violinists have come forward, so not sufficient to get off the ground, but come forward, so not sufficient to get off the ground. But that, if you're interested, there's a link in the news roundup where you can get hold of somebody. Looking forward to the festive season as it's rolling up to us. The Listening to Classical Music group are going to have another session. They're going to invite us all to join with them on a Zoom program of music for Christmas and the New Year. And the invitation will be coming out in the near future from Anne Trant. And the date for your diary is Tuesday, the 14th of December at 10:30. The IT Cafe, that group has been suspended due to COVID, but they're planning to resume meetings in the new year, and they're going to use a new time, Monday of week 4. So that means the next meeting, or the first meeting, will be Monday the 31st of January at 2 p.m. And it's hoping to expand it into not just your computer, but Wi-Fi and whatever else you might want to try and find out about. And lastly, you may remember that we're going to have a link up with Perth, Australia. That's happened, and after some friendly discussions, it was agreed we would exchange our newsletters and have a Zoom meeting about every 6 months. So if anybody has anybody out there who wants to get in touch with somebody, if you get back to me, I can link up with the people from Perth u3a Scotland who are going to talk to Perth u3a Western Australia. Thank you very much.
Thank you very much, David. John Burgess was unlucky enough to be a colleague of mine for many years. He's a fine mathematician and physicist, and also a keen walker, photographer, and astronomer. He has a special interest in space exploration, and in particular the science involved in sending missions to Mars. I'm delighted today to be able to ask John to speak to us. Ah, there he is.
through loud and clear? As ever, too loud and too clear. My apologies for that. Excuse me a second. We've had some slight technical difficulties, so the talk isn't going to be quite as I'd intended. One or two elements will be missing, but hopefully we can get the vast majority in here. So Robert kindly asked me to speak on the subject of our missions to Mars. And basically what I'd like to do is not to do a technical talk, so many of you please don't worry about that. But really to take through the ways our views of the red planet have changed over my lifetime. Now, when I was born, it was before the internet. Can you remember that? We used to have these things. They were called books. This is a venerable Larousse Encyclopedia of Astronomy, 2nd edition, 1962, which assured me that what I'm looking at here, Mars, there was enough pressure in the atmosphere for there to be a possibility of liquid water on Mars. We now know that's not true. The true atmospheric pressure on Mars is about 1/10 of what we thought in those days. It also assures me that there was still the outside possibility that these darker regions, which you can see on the photograph, could possibly be vegetation. We now know that that simply isn't true, the different rock types. It was 2 years after this was published, 1964, when the first space probe actually was sent past Mars to give us a better view. But I suppose when I was born, we'd moved beyond that time when H.G. Wells brought us War of the Worlds back in 1897 and had this rather splendid view of Mars as a dying planet. Where have you heard that before? An advanced race had to deal with this. They had their own version of COP26, concluded that their planet was doomed, and the best thing to do was to invade the Earth, which they did fairly successfully. In fact, to put not too fine a point on it, they whooped us. So much so, sorry, it's not coming up. You were supposed to be able to see Tom Cruise there, who was the last person to appear in the film of War of the Worlds, but even Tom Cruise couldn't save us. Now, I mention that because towards the end of his book, he says that the Martians were defeated. And the thing that defeated them, if any of you remember, is very prescient in terms of the last 2 years we've been through. It was the bacteria, it was the microbes to which the Martians had no resistance. This was written, of course, in the days before vaccines, and I found that last little sentence particularly poignant, really. That by the toll of 1 billion deaths, man has bought his birthright of the earth. We're lucky to have vaccines these days. Anyway, carrying on. This is about as good as it gets from seeing Mars from the Earth. This is a photograph taken by the Hubble Space Telescope. Now, observing Mars before the space age was always a really great problem. To explain, here we have, excuse me, I'm working on this laser pointer, that's it. Here we have a view of the solar system. This was supposed to move, but unfortunately, that was one of the things you can't do. That's it. Solar system, the sun in the center, the planets going round it. At the moment, this is the way it is. The Earth is on this side of the sun, Mars is away on the other side of the sun. It's about 250 million miles away. To put that into context, if you sent a radio signal across to Mars, it would take 20 minutes to get there. If your friend in a colony on Mars received it and wanted to answer, it takes another 20 minutes to get back. In other words, it takes 40 minutes to do the normal thing of saying, "How are you doing?" "I know, bad." So you'll appreciate that it becomes very difficult to actually hold conversations with anyone anywhere near Mars. Similarly to when we send robot spacecraft, the same applies. When you see things like these spacecraft landing, they've just got to be programmed to do it and let them get on with it. Because by the time they've actually landed and sent the information back to Earth, well, it's happened, and it happened many minutes ago. Carry on. So anyway, if you look through a telescope from Earth, that's what you're liable to see. And every 2 years, Mars comes particularly close to the Earth, and you kind of get the best of views. But people were able to see things. They saw seasonal changes. The polar caps get larger, get smaller. The dark areas seem to get lighter and darker. There were definite seasons on Mars. And here's a set of photographs showing that. You can see the polar cap larger in the summer and then larger in the winter. And as you come towards the summer, it gets progressively smaller. We now know the reason for that. Basically, it's so cold. No, I don't. Sorry, that's another one that's not showing. It was supposed to be a photograph of the polar caps, and it's so cold at the poles of Mars, there is a permanent water ice cap. But we now know that in the winter, it gets so cold that the carbon dioxide itself will freeze onto the surface. And something like 30% of Mars's atmosphere, which is largely carbon dioxide, can end up frozen at the poles in an area about 1 meter thick. So what we see in the seasonal variations are this polar cap coming and going. There's a permanent water ice cap. However, you get the carbon dioxide seasonally appearing and disappearing. There were darker areas on Mars, the ones that some people used to think were vegetation. Turns out that these are different types of rock. This is a basalt. It's a thing called a shield volcano, much like the Hawaiian Islands, but a lot lower. You can also see on this that Mars basically is a desert planet. It's a very dry and dusty place. And dust, in fact, is one of the great things one would ever have to contend with on Mars. To show you in 2018, on the left in May, you can see a dust storm starting. By July, you couldn't see any of the surface. The dust had entirely enveloped the planet. And unfortunately, underneath that one was one of NASA's longest serving servants, the rover Opportunity, and unfortunately it succumbed to that dust storm. It didn't survive the side. So dust is an incredible feature of the Martian surface, of the Martian environment. And here's a wonderful photograph I came across of that dust storm actually in progress, trundling across the surface of the planet. The wind's just whipping up the dust, and eventually, as I say, the whole globe was encircled. Now, I suspect we're at the start of a new space race, or actually probably quite well involved into it. By that, I'm not talking about this sort of thing. This is a sideshow. Much as I take my hat off to Bill Shatner for boldly going where no non-octogenarian has ever gone before, and believe me, yes, I did have to practice that sentence a few times. Far more serious is the fact that since the end of the Space Shuttle program in 2011, America has been unable to send men into space. It's had to pay the Russians to do it for them. This is changing because a genuine visionary, Elon Musk, and whatever you think of him, he is a genuine visionary. He's now doing this. He has his own corporation, SpaceX, and this is their Falcon rocket in the middle. You'll be glad to know it's not electric powered yet. However, that's how NASA are now getting people to the space station. It's flown the first 3 or 4 successful missions. But not content with that, he's a dreamer. He wants to go to Mars. Now, this thing looks a little bit like one of those have I got news for you, sort of what's all these things got in common. Well, Elon Musk wants to go to Mars. He doesn't just want to go on to Mars, he's thinking about colonizing Mars. And this quote he has here, he's realizing with the difficulties of communication between a Mars colony and the Earth, the sheer isolation of it, that it will tend to become increasingly autonomous. Hence, we'll make our own laws, quote. Oh, sorry, that's the inside of his space capsule and 4 happy NASA astronauts on their way up to the space station. Anyway, if we go to Mars, we're going to have to build somewhere to live. You're going to be there for a long time. You're going to have to build a biosphere, which is going to have to be completely self-contained and be able to grow all our own vegetables and so on. So I was intrigued to come across a news report on the radio a couple of weeks ago, which I had to go and check out, that people have been doing some more research on this. This is something people are looking seriously into, but to find out if it was true, I had to go to the Heinz website. Because believe it or not, Heinz have a Mars edition tomato ketchup. Such a serious point, the Heinz tomato growers and the Florida-based Aldrin Space Institute have been looking at growing tomatoes under Martian conditions. If you've ever got to go and live on Mars, this is the sort of thing we're going to be able to do, and at least the astronauts, when they finally go there, will know that they've got ketchup to go on their bacon rolls. Where they get the bacon from is another question. Anyway, it takes two to have a race. So we have Elon Musk and Heinz on the one side, backed by the Americans. On the other, we have these chaps. China is to be taken very seriously. Earlier this year, they launched their own space station. Next year, they're going to put 2 more modules up onto it. In terms of manned exploration, they are right up there. In terms of robotic exploration, they just this year flew their first mission to Mars, which sadly doesn't seem to be appearing, which was a great success. Go back to one we've got a picture. They actually not just orbited something around Mars, they landed on Mars and then deployed a rover to trundle across the surface of Mars and see what was going on. Believe me, that is a tremendous technical feat, especially for their first mission. More sinister, we're hearing that they have been trying out what they call it, the hypersonic launch systems for missiles. That was just on the news this morning. China ought to be taken very seriously. Their declared aim is to do a manned mission to Mars by 2023. Sorry, 2033. Give them 12 years. Right. So, the question is, why send men in the first place? Why not just send robots? Robots are far easier. You don't need to feed them, for starters. They'll trundle along quite happily. They'll not argue back to mission control. And they're incredibly intelligent. They're getting better and better. I mean, as you can see from this, they've even got to the point where they can take selfies. Okay. Many probes have been sent to Mars, many have failed. Sadly, some of you might remember this little chap, Beetle 2. If you don't remember this chap, you might just remember Colin Pillinger, who was the very determined and very enthusiastic scientist who cajoled the European Space Agency to allow Britain to send their own little rover or their own little probe to Mars. It was Beetle 2, and very sadly, Beetle 2 went into its landing mode and was never heard of again. Everyone assumed it had crashed. It hadn't. Later on, they actually managed to take a photograph and found it on Mars. It was intact. Sadly, what had happened was that the solar panels, 2 of them, hadn't unfurled. This trapped the communications antenna, and poor little Beetle 2 was sitting on Mars, but unlike E.T., was unable to phone home. So, 1964, Mariner 4, the first flyby, our first chance to really get a view of what the surface of Mars is like. Great excitement, great disappointment. It looks far more like the moon than any Earth-like planet that we had any hopes of. It dashed our hopes for anything like an Earth-like planet. This is a very ancient landscape. However, it had only looked at a little bit of Mars. So hopefully, if we look at more, we'll find some more interesting things. Mariners 6 and 7 were sent, did a similar thing. These things just flew past the planet, disappeared into space, took a few photographs while they were doing it. Again, you didn't see much different. Craters, looks much like the moon. So eagerly awaited was Mariner 9, which was the first successful orbiting mission. To get to Mars, you've got to go very fast. You've got to leave the Earth about 25,000 miles an hour. When you get to Mars, if you want to stay at Mars and go into orbit, you've got to slow down again. Probably lose about 3,500 miles an hour. Mariner 9 probably weighed about twice what the earlier Mariners did. Not because it was different as a probe, it simply had to carry so much more fuel to actually slow down. But it did it successfully. It went into orbit. So everyone very excited. Disappointment. Guess what was happening at Mars? You know those global dust storms? Mariner 9 happened to arrive just as there was a global dust storm on. So it didn't see very much for a while. Some tantalizing things. Look at these. You can see, what the heck are those? The little black dots are just artifacts of the image processing. They're nothing to do with Mars. What are those things? Well, when the dust finally settled, a very different view of Mars, completely missed by the earlier mariners, was found. Mars has some amazingly large landscapes. These are 3 so-called tharsis volcanoes. They're examples of shield volcanoes, which are like the Hawaiian Islands, that you have a hotspot in the crust through which magma rises, and gradually, through successive eruptions over a long period of time, you build up a large volcano. Well, Mars has the greatest volcanoes in the solar system. This one, Olympus Mons, is the largest of the lot. It's bigger than any other volcano that we know of in the solar system. Here's a rather lovely image of it. One of the things he managed to do is to take some great images of Mars. Sometimes they're not quite all they seem to be. Quite often these things, it's not really photoshopping, it's not really cheating. But 2 things are done on Mars. One is simply to measure the shape of the surface. It's called a digital terrain mesh, DTM. But basically it gives you a very accurate idea of what shape the surface of Mars is. You then perhaps a photograph taken from straight down, and by combining the 2 with a lot of clever computer imagery, you can then lay the photograph across the surface, and then you can look at it from various different angles. And some of the wonderful images, and it's not cheating, it's simply using the resources we have to give us the very best images of Mars that we can get. Anyway, Olympus Mons, greatest volcano in the solar system. Here's a comparison. Everest 5 miles high, Olympus Mons 15. Largest shield volcano on Earth, Mauna Kea, 6.3 miles up from the ocean bottom. Still, Olympus Mons is about 1.5 times as big. Well, why? Basically, it's because Mars, compared to Earth, is a pretty dead planet. There's no plate tectonics on Mars. At the Hawaiian Islands, you get a chain of islands because the hotspot is there, but the plate is moving across the top of it. So it builds up a succession of several shield volcanoes, and those are the Hawaiian Islands. On Mars, no such thing is happening. Olympus Mons just sat there and kept getting bigger and bigger and bigger until the magma stopped flowing. Anyway, massive volcanoes. A huge valley system, the Valles Marineris. If the west coast of America was there, Los Angeles, the east coast of New York would be across there. It would span the entire continent of North America. The Grand Canyon would fit into one of these little side canyons. This is landscape on a vast scale. And here's a more detailed view of the interior of the canyon. It is an incredible landscape. And it's one of those that if you were to land on Mars, you'd love to go there and just have a look around and do a bit of hill walking and so on. But sadly, I think that's in the future, and I don't think it's going to be me who's doing that. Anyway, we've orbited Mars. We've found out what's there. What's the next thing you want to do? Well, obviously, you want to land on Mars. Some of you might remember this chap, the Brian Cox of his day, Professor Carl Sagan, probably best known for his television series Cosmos. And here's Carl Sagan beside a mock-up of the Viking landers in the deserts of America. Now, it gives you an idea of scale, but in terms of landing sites, there's no way they would put a lander anywhere near a hill like that. The first time they tried to land, you find the flattest, most boring part of Mars, and you go and land there, because it's the safest thing to do. This boring and flat part of Mars went under the rather optimistic title of the Plains of Utopia. So, ladies and gentlemen, straight from the Martian Tourist Board, the Plains of Utopia. What it does have, This was an early morning view. That's frost. You did actually get some frost forming on the surface of Mars. So you might not get liquid water, but you can get frozen water. So those are the Vikings. They actually sent some experiments up to try and search for actual signs of life on Mars, present life. It's still controversial. There's a thing called a labeled release experiment, and the principal investigator for that, who sadly died earlier this year at the age of 97, to his dying day maintained they did find evidence of microbes on Mars. It's a minority view. Most people think that the Martian soil had a very different chemistry to the one we expected, and some weird chemical reactions produced the results they got in the experiment. The jury's still out, but it probably is chemistry rather than biology that they discovered. Anyway, going to Mars, it's a risky business. The Vikings were successful. Some haven't been. Poor old Schiaparelli, the European Space Agency, sent this off in 2016. Now, Schiaparelli plunged into the atmosphere like they used to do from the old Apollo missions, slowed down by the friction in the atmosphere, deployed its parachutes, all going fine, until it started to spin. They don't know why, but it started to spin and kept spinning faster and faster. This rather confused the computer. In reality, Schiaparelli was 3.7 kilometers above the surface. The computer came to the conclusion, not only had it landed, it was actually below the surface. It then came to a very reasonable conclusion, if I'm on or below the surface, why do I need a parachute? So it jettisoned the parachute. It then realized it had been supposed to fire its retro rockets, so it did for about 3 seconds, before again it decided, well, if I've already landed, why am I firing my retro rockets, and stopped doing that. It then decided, well, I'm here, I might as well phone home. And just and so managed to get one little package of data back to mission control before reality struck. And so did this thing, hit the surface at 540 kilometers per hour, they assume. There have been many varied and inventive ways of managing to get things wrong on Mars. It's not an easy thing to do to make one of these missions work. Anyway, you're going to send these, where do you send them to? NASA has always had the view that if you're going to look in places, follow the water. Where there's water is liable to be more interesting than where there isn't. So they've done that. Now, sadly, at the moment on Mars, it's very much a case of the ancient mariner. There is a lot of water left on Mars, but where is it? There's not a lot to drink. Here's a view of the various landing sites which have taken place. The Vikings here and here. The next set I'll show you is Pathfinder here. The latest one, Mars 2020, actually came down in a thing called Jezero crater across there. And I'll say a bit more about those in a second, but first of all, a little word for the Phoenix lander. The Phoenix is sent to the Arctic. I'll not spend a lot of time on it, but it did come out with a rather... Oh, sorry. Sorry, that will happen again in a moment. Sorry, just before we do that, evidence of water on Mars. There might be none on the surface now, but there certainly was in the past. Here's a set of chasms which appear to have been produced by catastrophic floods. Several incidents of them. The flood water came from here, swept down and into the area down here. You'll notice at the downstream end of these islands, these little tails. That's where the water was depositing material and gave these very distinctively shaped islands. So water has certainly flowed on the surface of Mars in the past. Someone suggested, in fact, there was even a large ocean on Mars. And general opinion is that, certainly in the past, there was about enough water on Mars to half fill the Atlantic Ocean. There's a lot of it. So where's it gone? Well, Mars is a small planet. It's not been large enough to hold onto its atmosphere. Most of the gases in its atmosphere have disappeared into space. And many people thought that a lot of the water had done the same thing. But more recently, they're concluding that a lot of it is actually still there. This would have been another photograph of the polar caps. Just use your vivid imaginations. They're sort of white, round. Hopefully the next one will work. Ah, yes. Here we have the Korolev crater. This is near the poles, and it's full of ice. They reckon there's enough ice there to fill Lake Erie 5 times. That's a fair chunk of ice. You could get a few G&Ts out of that. Underneath the surface, there seem to be layers of frozen ice through various sediments, and beneath the surface, where it's protected from the heat of daytime, there seem to be some layers of ice. Also, what they now reckon is that a lot of the water may well have just combined with the surface soil and rocks to form various things like the clays we have on Earth and so on. And that seems now to be an idea of where a lot of that water has gone. And because we know plate tectonics, it simply stays there. On Earth with plate tectonics that happens, but as the plates go around, the water gets released back into the system. So anyway, where do you go? Mars Pathfinder, here we go. Downstream of some of these little islands. This is the first one to go and try and land a rover on Mars. And here it is, having a look at a wee rock called Yogi, which is basalt, and apparently probably didn't come from that area. So the idea is that dear old Yogi had been picked up by the floods, brought down and deposited. Now, how do you actually manage to land on Mars? Well, here we go. Just show you a little video. This is how Pathfinder and Spirit and Opportunity came after it, landed on Mars. You go through the heat of re-entry, survive that. Out come the parachutes, slow you down. It's the next bit I love. Our little rover is inside there. Seriously, it worked. This is great. Slow down a bit more. And there you go. It's another advantage of sending little robots. I don't think many astronauts would agree to be landed that way. So there we go. Anyway, comes to a halt, airbags deflate, and out comes our brave little explorer to go and have a look around the plains of Mars. There we go. Perfect landing. Anyway, as I say, that's where we've gone. I was about to mention this little thing, Phoenix, which landed in the Arctic regions, and took this rather wonderful photograph of the midnight sun on Mars. Some of them, they've perhaps no scientific value, the photographs, but they're wonderful images. Anyway, going on, there were a couple more missions, Spirit and Opportunity, very successful rovers on Mars, found the first definitive evidence that yes, some of the margin materials had formed in the presence of liquid water. Curiosity was too heavy to be landed with airbags, so they used this thing, a sky crane. Basically, it drops on the surface of Mars, get rid of the cables, and off it goes again. And you've got it on the surface of Mars. They used that earlier this year on Perseverance. And if this works, that's an actual photograph of the Perseverance rover being lowered to the surface of Mars. Even better, we have a video. Sorry, I was going to skip the first couple of minutes of this, but technically I'm not quite able to do it. Anyway, there we go. Parachutes.
Confirm that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
This is, of course, mission control, who are at this point simply interested observers.
Slowed to subsonic speeds, and the heat chill has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
This is on the bottom of the rover looking downward. Later on, you'll find a split screen in which you also have a photograph of a video from the rover looking up at the sky crane and one of the sky crane looking down at the rover. That comes in the latter stages of the descent.
3.3 meters per second, altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface. Perseverance is continuing to descend on the parachute. We are coming up on
This is the first time they could actually detect, the spacecraft could detect what was beneath it and actually steer and avoid obstacles and try and find the best of a landing site. They're getting far better at really targeting specific landing sites, giving them far more interesting places to go to.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Well, the people who are watching this, a significant part of their working lives is to do with this mission.
83 meters per second.
If this doesn't work, someone has lost years of their lives
the surface of Mars.
in terms of their
Confirmation that the
profession,
back shell
the
has
work they've been
separated.
doing.
We are currently performing the divert maneuver.
They call it the 7
Current
minutes
velocity
of
is about
terror.
75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
Here we go.
Here in safety Bravo.
Right.
We have
This is
completed
where I
our terrain
intended
relative
coming in, but
navigation.
things happen
Current
more
speed is
quickly
about
now.
30 meters per second, altitude of about 300 meters off the surface of Mars.
You're about to see the jets
We have started our
firing and
constant
kicking the
velocity
dust up.
accordion, which means we are
And
conducting
now,
the sky
here we
crane-
go.
About to conduct the sky crane maneuver.
Watch this on the left.
Sky crane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the
Success.
surface of Mars, ready to begin seeking the signs of past life.
Some very happy people. There are occasions when you just know you missed a really good party. Okay, so hold on. So what happened to that sky crane after it disappeared off a safe distance and basically crashed? Not that NASA ever crashed anything. It went into an uncontrolled landing, apparently, or a ballistic fall was another way of putting it. Anyway, having done its job, it did crash. There we go. So, Curiosity's down in Gale Crater. They think there used to be a large lake in Gale Crater, and so it was going to find evidence of that. What it actually found was probably there was never a huge lake like that, but there were a succession of smaller lakes in there. Anyway, Curiosity sent some fantastic photographs back. Any hill walkers would probably love to go and disappear and explore them until you realise that there's actually no oxygen on Mars and the surface pressure is about 1/50th of what it is on top of Everest. So not a nice place to go walking, unfortunately. Of course, Curiosity, like all of them, had to send a selfie back. There we are. Doing its trundling across Mars, exploring, and again finding the evidence that yes, there was liquid water on Mars in the past. Okay, the most recent one, Perseverance. It landed within this area here. This was exciting because there used to be a river coming down here, and this seems to have been a river delta. And so they're going to hopefully be able to see evidence of what was happening over the succession of epochs when the water was actually flowing into the crater here. They kind of think this is what it might have looked like. There was a river coming in, the delta here. This is a mission which is in its very early stages. It's not returned a great deal yet, and it will take a while to do so. Here's one of the photographs it took of a thing called Kodiak Butte. It will go and take samples from there. But it'll be a long time before we find out what the samples contained. Because this one, instead of trying to analyse them on Mars, is going to put them into a group of samples, leave them on the surface, and a later mission is going to go and hopefully retrieve them, bring them back to Earth, and then we'll be able to get a look at the margin rocks and soil using proper scientific instruments rather than the tiny things that you're able to use on the rovers on Mars. So very much in its infancy, but one which will hopefully over the years produce exciting results. One thing, however, it's managed to do, the first helicopter on Mars, and with this I finish. You're about to see this little thing here. Can we have some more sound, please? This is the sound of the wind on Mars. Here's our little helicopter. As it takes off, you hear the hum from its motors. There we go. Drone flying on Mars. There is a rumour that it was sponsored by Jeff Bezos to ensure that once the astronauts get there, they'll at least have Amazon Prime to deliver their tomato ketchup. Anyway, disappears off, comes back in about a minute's time, so we'll not just sit and look at that. But there we go. We've learnt a lot about Mars in my lifetime, but there's an awful lot yet to learn. One final thing. Having spent a couple of weeks at the margin sort of doing all the research and looking at this, I finally came to the conclusion that, to be perfectly honest, much as Mars is intriguing, there really is no place like home. Thank you.
Hello. Thank you very much, John. Considering the trouble that John had when we started today trying to get the technology going, he's done an absolutely fantastic job to produce what he could. And before I say anything else, could I very much thank John Payton from the church here, who has done so much this morning to help us with that. Thank you very much. Now, I'm sure we will have some questions. I'll start off with, how on earth do you get there to Mars? You can't go in a straight line, can you?
You have to have a big rocket. It's kind of simpler to get to Mars than most others, but you've just got to get up to about 25,000 miles an hour from the Earth, point in the right direction, and basically you just gradually rise away from the Earth's orbit, come up towards Mars' orbit, and hopefully rendezvous with Mars. There's a slight variation on the theme. If you're just going to put a rover down, you just go there as quickly as possible. You're going fast and the atmosphere will slow you down. If you're going into orbit, you tend to take a longer route there, but you're not going as fast when you get to Mars. But really, it is just sort of a trajectory like that from the Earth, up away from the Sun, and down to Mars.
Right. Well, thank you. Any questions? Can I hand this around to anybody? Yes? You're doing the usual, aren't you? Sending me all corners.
Well, I accept that this may turn out to be a non-question, but I'll give it a go. Okay. It's about a modern H.G. Wells. About 7 years ago, I read a book called The Martian, and I wonder if you've read it. It was about an astronaut who was space shipwrecked on Mars, and the book was about the science of his survival for about 6 months until he could be rescued. Now, I wondered if you'd read it and whether you thought that the science was up to standard.
I'm afraid that's one I haven't read, so I apologise.
Well, it's a non-question.
I have read, there was a series of 3 books, kind of The War and Peace of Mars, I think they called it, by an author, Kim Stanley Robinson, who went through the process from the early colonies on Mars right through to what they call terraforming and turning it into a planet that became habitable for humans again. But I'll say the Martians, I'm not sure.
Anyone else in this area? Ah, yes.
Looking at the, can you hear me all right?
Yes.
Looking at the incredible detail of these photographs and filming coming, how long does it actually take from there to here for us to receive them?
What will usually happen is that the spacecraft obviously has its onboard cameras. It will usually store information on board and then literally just transmit it back as a radio signal to Earth, where the image will be recreated on Earth, basically as you would with digital technology now, or digital imaging. You can simply send the information as you would over the internet and reconstruct the image.
How long does it actually take?
To actually get the information from Earth to Mars, when Earth and Mars are at their closest, it's about 3 minutes. When they're at their furthest apart, it's about 20. Is the time it takes for a signal to get from Mars to the Earth. So it's about that time.
Sorry.
Thank you. Now, I was intrigued by the cameras. What powers them? Have they got batteries or? Sorry?
Yes, actually, it's a very good question. 3 of the rovers, Pathfinder, Spirit and Opportunity, were powered by solar cells, which turned out to be a very bad idea on Mars because of all the dust that accumulates on the solar panels, solar cells, and they very quickly lose their efficiency. Spirit and Opportunity were only supposed to last for 90 Martian days. They actually lasted for 6 years and 14 years, respectively, because what people hadn't thought of was during the seasons, the winds on Mars change. And the winds on Mars are actually quite good at taking the dust off the solar panels. Particularly, you get dust devils on Mars, and if one of those went across the top of the lander, then it was very effective at getting rid of the dust. But the other answer to your question is that most other Mars probes, certainly more recent ones, it's a form of nuclear power that they use. It's isotopes of plutonium or compounds of plutonium which will decay and produce electricity, in a sense, as a battery would. So apart from those 3, it's been nuclear power that they've used.
John, how sterile are the probes and Mars? Because I know when they sent some to the moon, there was those little, and I forgot the name of those little animals, they're very small, which seem to sorts of...
It's a very good question. It's one of the problems about flying probes out to places like Mars, that obviously we'll want to find evidence of Martian life. If it's there, what we don't want to discover is evidence of life that we took there on our probes. And it is a major issue. Most of these probes are and should be very well sterilized before they're actually sent to the launch site. Apparently one of the problems is with the I think it's hydrazine used as a fuel for the thrusters, that it's actually more difficult to sterilize that as well. So yes, it's a difficulty, precautions are taken, but mistakes could be made, has to be said.
I take it that if we are invaded by Martians, they'll be Chinese.
Could well be. Well, I mean, I would certainly not bet against the Chinese to be the first on Mars. Certainly, if they've given a timescale to it, 2033, knowing the way that the Chinese leadership are, they probably anticipate flying to Mars by 2033, and if they don't, there'll probably be questions to ask. So I think with China, you have that combination you perhaps had with America in the 60s. There's a real determination to show their technological superiority. There's national identity involved. We want to be the first to go to Mars. And they do have a great deal of ability. The missions that they've launched this year are very impressive missions. So I wouldn't bet against the Chinese being the first to get to Mars, and I certainly wouldn't bet against them doing it by 2033 like they've said. We'll see.
I think then I can hand over to Dave Smith to give a vote of thanks.
Well, thanks very much, everybody. Thank you, John, for coming along and giving us this really most fascinating talk with great images as well. And I second Robert's thanks to John Payton up there in the balcony in the gods, who has helped us with some last-minute solutions to some last-minute problems. And hopefully, if all goes well, this is going out live on a YouTube stream, which you can look at later using the link that was sent around earlier. And thank you for sorting out all the technical problems. It would have been terrible to have seen John making a crash landing at 540 kilometers an hour into the font. In fact, listening to John's presentation, I thought, well, in some ways our lives have been a little bit parallel, because I first got interested in astronomy in about 1960, and in 1962, my 10th birthday, my parents bought me a little telescope and Patrick Moore's The Observer's Guide to Astronomy, which I still have. So this is, however old that is, from 1962 to now. And just trotting through my memories of astronomical adventures that I've been involved in, well, I did do some astronomy, you know, with this telescope in my back garden in Dunblane all those years ago, and it was fascinatingly clear, terrific clear skies. So one of the things that happened was I went to university and studied physics with a bit of space physics, a bit of stellar physics. And you know what they say about something that is quite easy, really? They say, well, it's not rocket science. Trust me, stellar physics is rocket science. It's really, really hard. So I gave up university study and I taught physics instead. And I think you've been a physics teacher and a maths teacher as well. And later on in my career, I did an Open University course. And this Open University course was dedicated to studying the camera systems and the optics on the Mariner 9 Mars mission, which John's just told us about. And in fact, that was 1971, I think, that went off. Mariner 9 is still going round Mars, astonishingly, 50 years later. I think they expect it to crash down sometime next year. Cindy and I, living in Essex at the time, in 1999, we took a group of 6 families in our village bus. Yes, we co-owned a village bus at that time. Took a village bus, not on a mission to Mars, but a mission to northern France. Anybody guess why? Solar eclipse. Unmissable. If you get the chance, do go. Various other adventures as well. When I was still teaching back in 1980, I took a party of 6th formers to the Cambridge Radio Astronomy Laboratory. Now, if laboratory makes you think of a field, it makes you think of a building. It's not a building, it's a field. A very big field with some very big radio telescope dishes on it. And we got chatting to a guy there. He seemed to be sort of attached to our visit for a couple of hours. Very nice guy called Martin Rees talked to us and gave very interesting talks and answered all our questions. And I didn't discover this until about 15 years ago. 15 years after that visit, he was appointed Astronomer Royal. So I thought, well, I've met the Astronomer Royal. That's fairly amazing. And today I've met another astronomer, John, who's given us this fascinatingly prepared talk on Mars. And taken us to Mars, this strange, dusty, rusty planet. How many people want to go to Mars purely because if you live there, you don't have to do the dusting? And more importantly, he's brought us safely back home again. So, John, thank you very much for that most interesting journey. Thank you.
Thank you, Dave. I should say also my thanks to Dave, who has also been helping today. And indeed, the previous day or two, trying to learn the technology of the centre. We would be very grateful. We're trying various different places at the moment. We're very grateful for your feedback. If you have strong feelings about any of the places that we are using or trying out and so on, please let us know. Politely, please. Our next meeting is on January the 10th. I don't know where yet. And that is Jim McIntosh, who is talking about Hamish Henderson. And if you know nothing about Hamish Henderson, I suggest you do a bit of research first, because I don't. Thank you very much for coming along today. Thank you very much again, John, and have a very happy Christmas. Goodbye.